Alright, in this video we're going to do another example of induction. We'll prove that -1 plus 2 plus 5 plus 8 plus ... plus the quantity 3n minus 4, that's equal to n over 2 times the quantity 3n minus 5. So the first thing we'll do is just show this is true. We'll do our basis step. So the basis step in this case is going to be n equals 1. Okay. On the left side we'll just get -1. On the right side, and again, I'm asking myself, are these equal? That's what I'm trying to verify. We'll get 1 over 2. It looks like we'll get 3 minus 5. Well, on the right, in the brackets, 3 minus 5 is -2. -2 times a half is -1. So, okay, so the basis step is correct, is valid. Okay, so now we'll do our induction step. So again, the induction step, we assume it's true. We assume it's true for n equals k. Okay, if we assume it's true for n equals k, that's going to give us -1 plus 2 plus 5 plus 8 plus ... 3k minus 4. We're assuming that's going to equal, and then on the right we'll get k over 2 times 3k minus 5. And now we have to show that it's true for the value k plus 1. Okay, so we have to show it's true for n equals k plus 1. Well, if we plug that into the left side, we'll get -1 plus 2 plus 5 plus 8 plus ... We'll have 3k minus 4 plus 3 times k plus 1 minus 4. And again, I'm trying to ask myself in this case, is that going to be equal to k plus 1 over 2 times 3 times k plus 1 minus 5? Okay, so this is now, I'm going to justify that these two quantities on each side are equal, and at that point we'll be done. Well, again, by assumption, from -1 up to 3k minus 4, by assumption, that's equal to k over 2 times 3k minus 5. If we simplify inside the parentheses, it looks like we'll have 3k plus 3 minus 4, which will be 3k minus 1. And again, I'm asking myself, is that equal to k plus 1 over 2? Looks like we'll have 3k plus 3 minus 5. So 3 minus 5 will give us -2. And again, you know, just kind of asking ourselves again, hey, are these quantities in fact equal? You know, there's a little bit of different algebra that you could do, again, to kind of, I think, to justify this, hopefully, without too much trouble. To me, sort of maybe the most straightforward, but maybe a little, you know, a few more steps is just I'm going to multiply out the left side. We'll get 3k squared over 2 minus 5k over 2 plus 3k minus 1. Now on the right side, if we multiply things out, it looks like we're going to have, let's see, we'll have a 3k times k plus 1 over 2 minus 2 times the quantity k plus 1 over 2. And let's see, we could get some common denominators. So I've got 3k squared over 2. I would multiply top and bottom of my 3k over 1. We could multiply top and bottom of that by 2. That would give us 6k over 2. -5k plus 6k would give us positive k over 2. Then we still have our -1 left over. Let's see, on the right side, it looks like we would have 3k squared plus 3k. Each of those would be over 2. And then we can simply cancel out the 2's on our second part, and we would have -k minus 1. Well, let's see. Again, I should still have my question marks here because I'm trying to justify, in fact, that these are equal. So I'm kind of asking myself, hey, are these equal? 3k squared over 2 plus k over 2 minus 1. Well, let's see. I think we could get some common denominators again on the right side. if I multiply my k over 1, if I multiply top and bottom by 2, we would have 3k minus 2k, which would be negative k over 2 minus 1. Whoops, how about not negative k, how about positive k over 2, right? 3k minus 2k would give us positive k over 2, which is exactly what we want, okay? So almost messed up there at the last step. So 3k minus 2k will give us positive k. We now have the exact same stuff on both sides. That justifies the induction step, and that now proves the original statement.